Hey everybody, my name is Dan Friedman and I'm a data center technical solutions architect at Cisco. Um, I've just finished my DevNet Professional certification back on March 3rd. Today is March 14th, 2023. And um, the reason I'm creating this recording is because, well, first I want to introduce myself because I am contemplating creating a series of videos around programmability, and a lot of that content is based on information that I learned during my pursuit of DevNet Professional. So I wanted to kind of explain, my time in the industry, my background in terms of skill set, and why I personally undertook DevNet Professional and kind of what my path was. Because I suspect, like many of you, you may be coming from more of a traditional network engineering and architecture background like me, and kind of trying to find your footing in a new era of technology that is driven heavily by automation, orchestration, programmability, etc. So without much further ado, I've been in IT for 23 years. I got my start in 2000. I spent my first 4.5 years in what I call end user IT, so end customer. I worked for a subprime mortgage bank, and I started as a Microsoft certified systems engineer. So I wasn't on the Cisco side. I wasn't into network engineering or any of that. I learned desktop and server operating systems, then got a little bit more into security. And in my last year at that company, I got into Cisco networking primarily because the company had grown so fast. We only had one other network engineer, and I wanted to help offload his work, learn, and provide somewhat of an insurance policy to my company. Because if this one engineer got hit by a bus, they would have been pretty out of luck. So. Having that 1 year of experience in networking at that company, I was able to successfully transition over to working for my first Cisco partner. And I spent the next 17 years working at, I think, 4 or 5 different Cisco partners, primarily with a skill set based around network engineering and architecture. And that's, for me, my certification path started out with CCNA and then CCNP route switch, CCNP security, and eventually CCNP data center. And I maintained those certifications for about 10 years. Along that path, I worked for some partners that were very Cisco focused, other partners that weren't. And so I found that I got to work on a whole lot of technology. So I've also been certified in VMware, Juniper, Palo Alto, F5, Riverbed. And I've worked on other technologies like HP, Dell, NetApp, and EMC that I haven't been certified on. So all that is to say, I've worked on a ton of technology. You name it, I've probably touched it at some point. But what I noticed, right, is like you, is this transition to programmability and APIs and controller-based systems and all of that. So about 5 or 6 years ago now, which would put us at about 2017-ish, I taught myself Python. I signed up for an online course by a gentleman named Kirk Byers. He has a Learning Python for Network Engineers course for free that I highly recommend if you're a network engineer, because a lot of the programmability examples that he gives as he's trying to teach you the language are based around things or concepts or ideas or programs that you can write against network equipment. And so it's an interesting and sort of relevant way to teach you Python if you're already a network engineer. So I found that very useful, and I would highly recommend his course. He's also got some more advanced paid-for courses, but that freebie course is more than enough to get you started, to be quite honest. The rest of it's going to come from experience. And then about 3 years ago, I started aggressively transitioning my skills. I had a peer and who became a mentor of mine, and we sort of discussed technology at a high level and the direction that things were going. And he he suggested to me what I have outlined at the bottom of this slide, 3 areas really to focus on at the time. The first was programmability, automation orchestration, things I mentioned a minute ago, modern application architectures, and cloud. And so without really having, coming from a network engineering and architecture background, and without really having a fully complete idea of exactly where these studies are going to take me or where I'm going to land, I committed myself to this. And it started, if you look at the bullet just above programmability here in green, I started out by getting my DevNet associate, which for me wasn't too difficult. There were new concepts though. It was challenging, but it wasn't overwhelming. And then I studied Git and GitHub and GitLab and CI/CD concepts and Terraform, and I got certified as DevNet Associate, GitLab Professional Services Engineer, Terraform Certified Associate, Ansible, Docker, and Kubernetes. Those were all self-study. I got my Azure Fundamentals and Azure Systems Admin certificate. And I studied a product called Aviatrix, which really doesn't have a whole lot to do with anything else on this slide. But Aviatrix is one product that talks about multi-cloud and hybrid cloud connectivity. Cisco also has the Cloud Network Controller today, which competes with Aviatrix. Anyway, that's that kind of circles around more of my network engineering and architecture background. But they have a program called ACE certification, and it'll give you a good working knowledge of terminology across the top 4 public cloud providers. So for that reason, I listed it here. I think that was useful. So anyway, in terms of what I'm going to attempt to cover in this video series, really going to focus around programmability. There's a lot involved in that. I'm going to show a slide on the next page by modern application architectures here. If you do embark on DevNet Professional, you will learn about multiple different application architectures, common design patterns, evaluation criteria. It all kind of falls under that bucket. And then cloud, of course, right? So the 3 bigs are AWS, Azure, and GCP. And then finally, at the end, I've listed data, and I've listed it in red, only because that's sort of like for me personally, that's like the future frontier, right? Everything is becoming data-driven to a certain extent. Networks, while still very important, while we still need a number of individuals to understand at kind of like a CCIE level, the guts of how to troubleshoot when things go wrong, a lot of networking has been abstracted away. And so it's becoming commoditized. It's becoming more like a utility that people just expect it to work. And there's a lot less, I would say, network engineering and architecture roles in terms of available jobs on the market. But what you will see is a lot of job postings around data science and data engineering and all those types of roles, AI, ML related tech. So I feel like that's kind of the future frontier once I get past programmability, modern application architectures, and cloud. And for me, cloud is kind of the next thing on my list. So if I fast forward to the next slide here, these are some categories or items that I will be aiming to sort of discuss in the video series. And these are not, you don't view each one of these bullet points as a singular presentation. Data formats, there will probably be multiple presentations just to cover 4 different data formats: JSON, XML, YAML, and CSV. And then data models, we'll talk a lot about Yang. And then developer workstation setup in WSL2. If you're going to pursue DevNet Associate or DevNet Professional, you should be writing some code. And the DevNet Professional Blueprint actually recommends that you've got 3 to 5 years of coding experience before you undertake this certification. Now, I've known Python for that long, but I'm not a full-time developer. Again, most of my work is centered around network engineering and architecture, and since coming to Cisco, I do a lot of partner support. So my current role doesn't demand these skills, and so it was quite challenging, not just in the transition from my prior core skills to these new skills, but in lacking some development experience, right, from a day-to-day, day-in, day-out job responsibility type perspective. And if you are a developer, this probably is going to be too elementary for you. This is really going to be most interesting to you if you're like me, coming from network engineering background and trying to learn more programmability. So it's important to know how to set up your workstation, what tools to install, and how to install them. WSL2 is basically a Linux VM that runs on Windows, which will come in useful as you're going through exercises that require an access to like a Linux command line and so on. Okay, development process, we're going to talk about that. Cryptography and SSH, so basically SSL and SSH and how those things work, why we need them, and how to do certain things with them. Git, which is a source control technology that you can use on your local workstation, along with GitHub and GitLab, which are various remote repositories that you can integrate with your local workstation and upload your code to for collaboration with team members. Docker, Kubernetes, this is where we get into more modern application architectures, in particular microservices. Docker is not the only kind of container. We also have Linux, LXC, Linux native containers. LXC containers have their own kernel per container. So that's more about virtualizing the operating system, whereas Docker it shares a kernel with the host. Every container shares the host kernel. So Docker is much more about virtualizing the application. And then Kubernetes is obviously a platform or orchestrator for running container-based applications. And then CI/CD, CD, it's kind of a CI/CD is the typical acronym, but it stands for continuous integration, continuous delivery, and continuous deployment. And there's differences between continuous delivery and continuous deployment. So those are those terms, and that process is often related to container-based application deployment, but can be used for other purposes as well. And then we can talk about HTTP protocol, REST, which is it's not a protocol, it's more of a style of writing APIs. We can talk about APIs and associated tools that you would use to communicate with APIs on various types of systems. So Postman is a GUI, curl is a Linux command line utility, requests is a library that you can use with Python, HTTPIE is a package you can install on Windows, probably even Linux and Mac, that provides a command line HTTP client. Fiddler is a local proxy that you can install that will intercept any HTTP calls that you make, which is really useful for getting to know and understand HTTP protocol and headers. Wireshark can obviously capture traffic on the wire and help you see, what's happening at different layers of your protocols. And then ngrok, which is a utility that will help you expose a privately run server. So what I mean is you might be running a local development web server on, let's say, port 5000, and you want someone in the outside world, outside your home network or outside your corporate firewall, to be able to hit that server. And so ngrok basically is a proxy that allows you to map a publicly accessible URL and port to a privately accessible IP address and port, just for testing, right? This isn't something that you would run for production, and it would be temporary. Authentication and authorization are super important when it comes to APIs, and there's a bunch of different authentication methods, as well as OAuth for authorization. And then we can talk about configuration management tools, and I don't know all of these, so I will be focusing on Ansible when we do get to this point, and probably a little bit of Jinja too. There's pros and cons and differences between all of these different configuration management tools, but the dominant and I think most popular one today is Ansible, so that's where we'll focus our time. And then infrastructure provisioning tools, the most popular one there is Terraform. How is Terraform used? How is it different from Ansible? How is it related to Ansible? We'll talk about those kind of things and basic concepts of Terraform. And then Python tools. There's a whole host of these things I think of as Python tools. Paramiko is a SSH library, so it allows you to programmatically SSH to devices, but it's a very rudimentary library, which has certain challenges. And so I mentioned earlier this course by Kirk Byers for learning Python for network engineers. Kirk Byers is also the author of the NetMiko library, which provides certain enhancements over the top of Paramiko. Basically, it deals with some of the underlying problems that Paramiko presents because it's such a low-level utility, and it makes it easier to consume. And then Napalm is even higher level than NetMiko, and basically what this does is there's multiple different, network drivers depending on the type of device that you're trying to connect to. So for example, Cisco iOS or NXOS. And so you can load the appropriate driver, and based on that driver, it will help deal with the nuances of those particular types of systems. And it also adds some operational capabilities in terms of candidate configurations and config backups and those types of operations that you want to run against network devices. And then Nornir is essentially, it's very similar to Ansible in the sense that both of these tools are intended to allow you to run a series of tasks. Those tasks can be run in series, they can be run in parallel. Ansible, though, is an abstraction of Python. In order to use Ansible, you have to have Python installed on the control node, which we'll talk about when we get there, or on the device that you're managing. And if you're managing a bunch of Linux systems, then Python's typically installed. But when you're managing network devices, Python is not necessarily installed on all network devices by default. More modern devices that have a Linux kernel under the hood, yes, that's true. So the reason why Ansible is popular with most customers is because it's abstracted. You don't have to learn Python, even though Python is running under the hood. Essentially, what Ansible is doing is using Python to make API calls to a specific type of destination system. And so it uses YAML markup language to define things like playbooks and variables and that sort of thing. And for that reason, it's easier. It's a lower effort to learn, I guess, initially, than it is to learn Python, which is a whole programming language, right? So you don't have to understand, control structures, if, elif, else. You don't have to understand for or while loops necessarily, although you can do some of that in Ansible. But one of the issues with Ansible is because it's been abstracted, it has to be converted from this sort of abstracted simplicity that was created for the customers back into native Python. And because of that, it runs slower, it doesn't scale as far, and it doesn't execute as quickly, right? And it can be more difficult to troubleshoot. So if you're looking for something that is just like Ansible, but is native to Python and can be programmed in the Python language, that's where Nornir comes in. Then we have NX API CLI and NX API REST, and these are different programmability capabilities on Cisco Nexus platforms specifically. So NX API CLI allows you to send let's say a show command, like show version, to a network device programmatically to an API endpoint, and to receive structured data back. And then NX API REST doesn't actually send a show command. What you do is you hit an actual API endpoint over HTTP to affect the same functionality as the command that you would have put into CLI, but you're actually using a native REST API to talk to the NXOS device in this case, and you're really manipulating an underlying data model for that system. So a couple different ways to communicate with Nexus devices there. And then we've got netconf and restconf, and netconf is XML based. It is a means of communicating with devices, and the whole idea behind netconf was to sort of plug the holes of SNMP from a configuration perspective. So it's right there in the name, netconf, network configuration, right? That's something that netconf tries to do, and it does this using something called Yang, which is a data model. And one of the goals of netconf, right, was to try to abstract away the differences of different types of network devices. So let's take a 24 port and 48 port Cisco switches, and same on Juniper, HPE, and Dell. Now, all of these switches, essentially achieve the same thing, right? They move data across the network. They all have ports and they all run protocols, etc. So is there a way that we can provide a sort of universally formatted configuration that we can then apply to any underlying network device type? And so that was one of the goals of netconf, was to provide that level of abstraction. And then restconf is really an overlay to netconf, and all this really is a layer on top of netconf. And so instead of using XML, you can use XML or JSON formatted data. But what this does is it adds HTTP semantics on top of netconf. And what that does is it allows developers that are already familiar with consuming REST APIs in general to be able to communicate with network devices. Now, the other main difference between netconf and restconf is that netconf is more widely supported across a wide variety of devices, and restconf is less so supported, and supports a lesser comprehensive number of features, right? So restconf is doing some catching up with netconf because it came after. And then finally, you have the native REST API, right? And all kinds of devices, Cisco devices or any other kind of modern networking devices or appliances, all have a REST API. And so you can manipulate those devices, the configurations. You can collect operational state data using the REST API or associated SDKs. Now, Ansible, we kind of talked about that, very basic already. So when we cover Ansible, we'll cover the basics, right? Different tools, configuration, inventory, playbooks, plays, tasks, how to use facts, conditions, loops, and more. But the fundamentals of how you can get busy with Ansible and be effective. And then we've got telemetry, which kind of goes back to what I was saying a minute ago about telemetry is really about being able to better scale the SNMP polling capabilities. So in SNP, you've got a central management station. It polls all these devices. All those devices have to process requests and reply. And, there's certain challenges with that in terms of scalability. And so telemetry is all about having the devices that you want to monitor regularly send data back to a central management station without being polled. So this is, SNMP polling is sort of a pull, and telemetry is more of a push from the monitored network device to the central management station. And this provides a lot of data and intelligence around the current state of the network. And a lot of this data is put through AI and ML tools to help customers understand the state of their network, any anomalies that might be taking place, and help them realize problems on their network sooner rather than later so that they can get busy troubleshooting them and provide, ideally, have a plan of action when they first get that first phone call that, hey, something's wrong. And another thing that we may cover is 12-factor. So 12-factor refers to 12-factor app. And what this is are 12 evaluation criteria or considerations that you should make when you're looking at an existing or creating a new microservices-based application. So this is more of an application architecture type conversation. So anyway, I think this video is getting to be close to about a half an hour. I think that's a good enough intro. Hopefully that gives you, an idea on my background, maybe why you might want to listen to me or why you might not. Totally okay either way, no problem. But yeah, if you're interested in transitioning your skills from a network engineering and architecture background to a more modern skill set, which involves programmability, then this video series will be interesting to you. One final thing that I'll say is there are awesome resources available on Pluralsight. If you don't have a Pluralsight subscription, then I highly recommend that you get one. If you are a Cisco employee, you can get it through Cisco. I think it's charged to your team, and it might be $200 or $300 a year. It's extremely worth it. I highly recommend it, especially if you're going to pursue DevNet Pro. And I would highly recommend multiple courses by a gentleman named Nick Russo, Russo. He happens to also be a Cisco employee, multiple CCIE certified, and he developed around, I think, 8 courses on Pluralsight that cover a large amount of material that applies directly to both DevNet Associate and DevNet Professional. And I followed a curriculum that he created in pursuit of DevNet Professional. So for the DEVCOR exam, I think his material was very relevant and based on real-world automation and programming experience from his professional work life. And for the DCAUTO exam, I used the digital learning platform at Cisco and took the I think it's DCAUI course to prepare for that exam. So check out the exam blueprints. They are accurate, they are fair, and definitely check out Nick Russo's courses on Pluralsight. My goal here is not to recreate what Nick has done. He's done a fantastic job. I just maybe want to provide some additional context or maybe some shorter videos to help you get up and running with some basic concepts. That's all. All right, so thanks for listening, and I hope you find the video series valuable. Thanks a lot. Take care.